Greetings, my name is Nurfatin Amira Muhammad Usri. I am student of School of Mechanical Engineering from MEC602 Sharla. Today, I would like to present my paper on the athlete performance analysis via IoT-based GPS system. So, this is the presentation overview for today. Okay, before I explain further, let me describe what is GPS. GPS is a satellite-based navigation system made up of at least 24 satellites. PS works in any weather conditions, anywhere in the world, 24 hours a day, with no subscription fees or setup charges. The US Department of Defense originally put the satellites into orbit for military use, but they were made available for civilian use in the 1980s. The application of performance data analysis (GPS) is overlooked to the tools and techniques required for processing large quantities of data. The potential of GPS monitoring is seen effectively in sport to better manage players' performance, workload, and welfare, since the previous design and development of the wearable technologies with IoT-based GPS for sport application is quite complicated and high-cost production. Let me discuss on what, how, and why of my research about. What is the research about? The project aimed to develop and integrate a suitable and functional wearable technology system that is cost-effectively for performance data analysis. How it can be done? This mechatronic design interface the sensor, which are three axis accelerometer gyroscope sensor and GPS sensor. The performance of the system is tested in a controlled environment. Three types of testing were done: GPS tracking the exact location, tracking a total distance, and monitoring the speed. Why the research is done? The performance of the system is functional and cost-effective and can be used to monitor athletes' performance during a training or tournament. Let's go on the problem statement of the study. Nowadays, many devices and technologies are accessible with different capabilities, price, and qualities. The use of the video-based analysis techniques by current wearable technologies is one of the most popular methods of assessing the demand on the elite level athletes. These techniques rely on the post-processing of athletes' video data to evaluate the physical demand of tournament and training sessions. With continuous rapid developments in athlete monitoring device and wearable technology advancement, athletes are increasingly use a GPS-based monitoring device throughout training and tournament session. However, the design and development of wearable technologies with a IoT-based GPS for sport applications is quite expensive and high-cost production for youth-level athletes. So, the objective of the study is to develop and integrate a suitable and functional wearable technology system that is cost-effectively for youth athletes' performance data analysis. Let's go on the methodology of the study. The study developed and integrated a suitable and functional wearable technology system. Three types of testing were done: GPS tracking the exact location, tracking the total distance, and monitoring the speed. The wearable technology and smartphone were attached to the athlete with Blink and established tracker application on them respectively. Comparison between speed data and percentage of efficiency, comparison between longitude data and percentage of efficiency, and the last one is comparison between the latitude data and percentage of efficiency is analyzed and discussed in the result and analysis. There are 5 methods used in this study. The first one is a development of system configuration. Second is hardware implementation. The third one is a software implementation. Fourth is a system integration. And the last one is experimental setup. Following are the results of this research. Table 3.1 and 3.2 shows the comparison of longitude and latitude point generated between a wearable technology and smartphone. It shows both systems generate different value point of longitude and latitude because of the wearable technology developed use Neo 6M GPS sensor and the smartphone use iPhone GPS. This is the graph of comparison between longitude and latitude data, and the percentage of efficiency and error between IMAPs and Blink application. The accuracy of efficiency values for the database was calculated. However, the longitude and latitude values displayed from these two devices were almost accurate. This is because the MEC602 GPS module tracks its location in real time using available satellites. The MEC602 is used to decode the NMEA data into a reliable information. Although neither the Neo 6M nor the iPhone GPS was flawless in mapping the roads, they came extremely nearby. Both devices occasionally displayed the path from a top structure, which was entirely unphysical. The Neo 6M GPS did have a very small error, which was during the experimental. The distance between a point of a location at Blink application and IMAPs was around 20 meters to 30 meters only. So, table 3.3 shows the data of speed from GPS test and Blink application was collected. The real-time monitoring data was recorded by the athlete's performance during the running session. The performance of wearable technology system in a figure 3.4 and 3.5 shows the percentage error of the speed data and the percentage of efficiency recorded at 10 seconds interval for a total of 100 seconds. The highest accuracy of efficiency was a 99.784%, which shows at the 60 seconds of the training began. Out of 10 tests performed, there were 4 points were recorded speed data more than 1% of percentage error. This result shows the difference value of speed data between these two devices were 0.48 km per hour to 0.05 km per hour. This can be due to the small difference value of speed was affected by the delay of the Blink server to display the real-time data at the Blink application using a smartphone. The delay happened because of the Blink was a web-based service. This requires that the device chosen must be capable of connecting to the stable internet connection. In these studies, the athlete performance analysis via IoT-based GPS system was conducted at Sharjah. The performance of the system was tested, such as GPS tracking the longitude and latitude point of a location, tracking a total distance traveled, and monitoring the speed. The wearable technology developed achieved less than 1% of percentage error on location positioning, but the percentage error for the speed monitoring increased at some point. This situation occurs due to the delay of the server to display the real-time data on the apps using a smartphone. The results of the current investigation are necessary to evaluate the performance of the system to monitor the athlete performance such as speed, top speed, average speed, and location positioning during the training session. Therefore, the replacement of the internet connection used into the system is needed to enhance a better performance of the system, and the use of the other mobile application that can monitor the real-time data while storing all the data is crucial to minimize the human error while collecting the data needed. Okay, the last one is this is the prototype of the wearable technology that it has been used in this study. That's all from me. Thank you.